Hello, everybody. Welcome to our first TNT lecture this academic year. I'm really honored. It's a great pleasure and a really great honor to have these two amazing guest speakers today speaking on a topic, a really hot topic that we're all interested in. And what's more, including a hands-on session as part of their lecture. Bonjour à toutes et à tous, soyez les bienvenus à notre série de conférences TNT. C'est la première cette année académique. Et voilà, aujourd'hui, nous avons deux conférencières vraiment remarquables, Julie Birkholz et Sven Lieber, qui vont parler sur un sujet très actuel, les données liées, link data, et leur conférence va inclure une partie hands-on, une partie pratique concernant les link data et les Wikidata. I will now just read their bios, and then we'll move on to the talk per se, and then we'll be back for the Q&A. Julianne Birkholz is Assistant Professor of Digital Humanities at UGent and lead of the Royal Library of Belgium's Digital Research Lab. Her research expertise is in historical social network analysis. From 2017 to 2020, she was a DH Fellow on the ERC Agents of Change research project We Changed, investigating the historical networks of women editors, periodicals, and organizations in Europe, as well as the research data managers for the linked open data of the bibliographic information of these editors. From 2014 to 2017, she was a postdoctoral researcher at the Center for Higher Education Governance, Ghent, researching the identification of social networks through web data. She holds a doctorate in organization sciences from the VU University Amsterdam, the Netherlands. Given that the study of networks, both theory and methods, crosses disciplines, her research is inherently interdisciplinary. Her most recent research explores a computational method for extracting social networks from historical newspapers. Welcome, Julie, and thank you so much for accepting to give this talk. And the other lecturer today is Sven Lieber, who works as data manager for the Royal Library of Belgium, KBR, and pursues a PhD in Information Engineering Technology at Ghent University, ID Lab, IMAC, which he currently is finalizing. I hope I read that correctly, right? ID Lab, IMAC. His work and research focuses on knowledge graphs and fair data. Within KBR, Sven currently works for the Beltrans project examining literary translation flows in Belgium between French and Dutch in the period 1970-2020, involving the creation of a fair corpus of contemporary Belgian authors and their works. During his PhD, Sven investigated the modeling and use of constraints in knowledge graphs and how users could be supported with visual languages for the W3C recommended constraint language Shackle. Sven has been involved in several national projects such as Be Social, aiming for a sustainable strategy for archiving and preserving social media in Belgium, or FAST, concerning the improvement of the customer journey when interacting with public services. He's the author and co-author of several peer-reviewed publications presented at prominent conferences such as the International Semantic Web Conference, the International Conference on Knowledge Capture, and the ACM Conference of Web Science. Thank you so much again, Julie and Sven, for accepting to give this talk. We've been looking forward to it. I can, myself, of course, but I can tell you that about my students and some of the senior researchers here and professors. They've been looking forward. We've all been looking forward to this, and thank you so much. Without further ado, and impatiently, I'll give the floor to Julie and Sven. Welcome, and thank you so much again.
Great, thank you. Thank you for having us, Chris, and students and colleagues from UCL. We're delighted to be here today. If you didn't see in the chat the message that I put there, please click on that link, because I will come back to that in a few moments. It's a linked data stories app that I'm going to share with you today. I'm now going to share my screen. And hope you can see that. Great. So I'd like to get right to the punchline first about what we're going to talk about today. So really tell you the end conclusion already. But making information on historical, cultural, social materials, and artifacts available for both humans and machines is very important. In making information available for computers to assist us to sort through, identify patterns, enrich our data is one of the most important things that we can do as a scholar. Not only publishing about this knowledge, of course, but sharing it in multiple ways to different communities. And one of those communities is Wikidata. And more generally, structuring this information as linked data for other humans, but also machines to read. So today, Sven and I are going to walk you through 2 examples of how sharing this data as linked data affords our work in the humanities and the cultural heritage sector. We're going to walk through this first through the example of We Change Stories, which is the app that I showed you there. We're going to explain to you what is linked data, what is Wikidata, what does this have to do with cultural heritage, literature, history. Then another example of the Beltrans project, KBR project, which is coordinated by KBR, which Sven will explain to you, and then show you some examples of querying and using Wikidata. And then indeed the hands-on session where you're really going to do some Wikidata queries today. Don't worry, you're going to be able to do it. So that's where we'll lead you today. Again, I hope that you've been able to load this app. It does take some time, so if it's not loading yet, just give it some time, be patient. If you already are there, I would encourage you to start scrolling through, looking at the images that you see there. These are Wikimedia images, so images that are publicly available through the Wikidata community on women editors in Europe. There's also a search bar on the left under collection here where you can do searches. What you're looking at, though, is linked data stories of women editors from 1710 to 1920 in Europe. And it was during this time that women's access to public life and to political power and decision-making was limited. And women were often excluded from formal education, and they lacked many fundamental legal, political, and financial rights, most notably, of course, the right to vote. In the ERC We Changed, or Agents of Change project, we revealed that the print medium of the periodical offered women an alternative means to make their voices heard far beyond their immediate sphere of influence through print, through the periodical. And as editors of their own periodicals, women were able to establish transnational networks of intellectual exchange across Europe to engage in cultural transfer and to position themselves in the contemporary debate as makers of culture and arbitrators of social values, proponents of rights. And core to this project, which I'm here representing this project, but it was actually a team led by Professor Marianne van Roormortel and 4 PhD students and 2 postdocs, was making the stories of these people, the women editors, but also those that they worked with, that were on their editorial team, their partners, their families, so these people, the places, and the history more widely known. And thus, we aim to ensure that this information was publicly available for further use by researchers and the public. And it is here in the Stories app that you have a user-friendly way to go through these linked data stories of over 3,000 editors. These were 3,000 individuals and editors that we categorized and put together in a relational database during the We Change projects, but then we remodeled into linked data, shared this on Wikidata, and in that moment, we were also able to bring together lots of other publicly available information that was structured in the same way to develop over that an app with the Science Stories team. And that's Kat Thornton and Kenny. Oh my goodness, I forgot his last name. I'm so sorry, Kenny, if you see this. But in any case, a great talented team of science stories. And you can see here on the left what that app included. So we have the library of these individuals, so really what authored works they have, but also editors of these periodicals, a timeline available of birth or death or other important dates that are stored within Wikidata, significant places where we know they have lived or perhaps even traveled, images of them that are publicly available, relevant people, and Wikidata statements, and the list goes on, because these resources are those that are connected to the wiki, to Wikidata, but also through federated queries. So really where we can bring together this publicly available information that's structured as linked data. So what is important is that we see this app then as a starting point for where people can come and they can search through these editors and find other publicly available information. So it's an entrance point. And you can also go through these stories and read them like we would as a human, of course, read these biographies, but in a way to know that all of these statements can be found within Wikidata. And that these stories, these biographies that we're reading, a machine put together for us. And that is the concept of linked open data stories. And this app, as user-friendly as it might be, or as nice as it is to see all of these images together, could only be created if we structured information in a specific way. So it was only possible with linked data as its backbone. Before I tell you a bit more of that, I think we need to take a step back. So it's great to know that that's possible, that we're able to develop these, that we're able to bring together previously distributed information, that we can bring it together and view it in different ways. But traditionally, as scholars, we don't necessarily have, let's say, the toolbox with us to do that. We start actually most commonly as a humanities scholar to go through different types of sources. And I'll start with the example of textual sources, since that's my expertise. So a human would go into the archive and we would look for a textual source. And if we were looking for, let's say, to build a biography on a woman editor of this period, we would start searching not only for evidence of their work, but also bibliographical information. So we would look for a birth certificate. And then we would look for certain things like a birth date, a place of birth, confirming their name spelling, while someone else might be searching for that same person or wanting to understand periodicals as well, but they're looking at different information. Perhaps they noted down the birth weight or their parents' names or the location of the birth. So every research project that we have lets us go into the archive with a different set of questions and also view that material in a different way. And that's really important for also how we try to understand and make sense of the patterns that we're viewing as a human. But what's also important is that we have a uniform way to store and organize as much of this information as possible. And in that way, what I want you to think about is not necessarily a database, but actually just starting to structure data and structure information. Even if we're not a digital humanities scholar, it is natural for a human to want to sort through this information into categories. And so we might even do that by writing this down and making different tables. Sometimes this is called a code book or a manual, which where we identify where different rows would be perhaps items, so a person or a place, and then descriptors of that item. And this, of course, in structuring this data in what we might think of as a spreadsheet, we're able to go through this in a more structured way, connect periodicals to editors, make selections, explore relations, but also distinguish what at this point now is data. So before we were looking at textual information, we as the researcher were processing it, we were trying to make sense of what we were seeing. From the moment that we start structuring this in a way that the computer can read, this is what we say as data. So these spreadsheets are great. They give you lots of information, but largely this information, of course, is relational. So this means that this information that we're trying to make sense of and these patterns of this data is that it's related to each other. And so we have to understand that these can be connected and largely through a signifier. So here's a really simple example of an interaction at a store. So this could be a record of a patron, someone who's, if I was at a bookstore purchasing a book, but this also could be mapping an individual that works as an editor, right? We have one element where someone has purchased something. We have an ID for that item. We know what that item is. We know how much it costs. Then we also have information about the purchasing date. And then we also have information about a customer. So all of these things are related. So this one transaction, this one view of looking at the archive could be that we're only looking at it in a flat space, one of these sheets, or that we want to understand these relations. And largely then from that point on, we need a database. And what I mean by a database in the most general term is we need a container to store this information and to structure this information. So this allows us then, this could also be media or unstructured text, but it aids us in sorting and identifying specific patterns, considering larger amounts of information and analyzing these, so mapping and comparing data points, so looking at things like averages or least and most common behaviors, trends over time. And of course, again, this doesn't have to be a computer, but computational approaches allow us to increase this velocity, volume, variety, and veracity. And what I mean by that is not only the size, but also the time, the efficiency that we have to do it, and also the quality is often enhanced because we're doing it in a uniformed way. So it helps us to remove anomalies as well. So great, what does this then have to do with linked data and Wikidata, and then of course, cultural heritage and literature? So what's important is that when we're thinking again about how we structure information, is that the way that we structure information influences what we can ask the database or what we can ask of these materials later. So if we not only didn't include, going back to the birth certificate example, information about birth weight, well, of course, we then can't go back to find that in a database, whatever its structure might be, unless that would have been included in our data model in the information that we stored. And as I showed you in this example, a lot of this information that we're collecting, it's not flat. It's not just one list of one individual and their characteristic, but also these relations between that. And so moving beyond the flat database, a way to store knowledge is in the structure of linked data. And I'm sure some of you have heard that term before. And what it affords us to do is that it gives us a structured ontology. So an ontology is a way of modeling this information. And one ontology is RDF, a resource description framework, apologies. And so what it extends the way that we can, because of the way that we structure this information, it extends the way that we can share this information and merge this knowledge together. This has often called as like a global database. So what you see here is the 5-star model of how we think about information. And I think this is a really good one, especially for humanities scholars to understand, because a lot of humanities scholars, and we should be happy that we have a digital copy of something that we perhaps can view from anywhere, which is a PDF. And then we can move to more structured information, which let's say is an Excel file, to a CSV, to RDF, to this linked open data. So for each step that we make, we gain more affordances in extracting and reusing that information. I want to emphasize that you don't need to understand every aspect of the semantic web, which is this backbone of this linked data, or even these technical parts to start implementing it. But most importantly, if you do want to do that, if you do want to move from archive to database to inputting data, let's say in Wikidata of the example today, then most often this is done with a group of experts. So it's done in humanities with those that have knowledge of the Wikidata community or have technical knowledge of linked data modeling to help you figure out the best way that you can take this information, model it as data into specific vocabularies or schemas. So what you do have to understand is that there are lots of different ways of modeling this knowledge. There's no one right way, but there is certainly a way to ensure that you can efficiently and accurately connect this information to other publicly available information stored in the same way. And the way that we do this is a triple, or a semantic triple, an RDF triple. And here, this is where we develop statements, a subject, and a predicate, and an object. This is a really common one that you see on the web of a description of Mona Lisa. So really, Mona Lisa, who is the creator? Da Vinci, what is the title of this object? And also then on the other side, on the left, Bob is interested in this painting. So you can see here very diverse knowledge that can be captured. Not only, let's say, these historical facts or information stored as a subject, predicate, object, but even other ontologies, other ways of modeling knowledge to know about how Bob might be related to this object. So again, this codifies something, and when we put all these statements together, this is called a triple store. The triple store, again, is just like the structure of organizing and storing these statements so that then we can efficiently ask the computer, hey, computer, can you please help us find all of the things that Bob is interested in? Or can you please help us find all of the titles of the paintings that Leonardo da Vinci painted? So it's really based on structuring this information in this way so that we can ask all sorts of questions to this data. So what does this have to do with cultural heritage or literature or history again? I'm going to go back now to my example of wheat change. So if this was my research question, which this was one of the research questions in the ERC project. So in the 19th century in Britain, we saw changing roles of women, where women served as editors to periodicals, and to understand who they were and hypothesize about their roles in history, the press, and the daily functions, we need to map these networks of their intellectual exchange and pay particular attention to periodicals that they edited. So this is a statement that we can understand as a human what the concepts are, but now if we would like to model this as linked data, we want to pull out what is that important information and these properties that we need to capture. And we did this within the WeChange project by developing a linked data model for periodicals. And if you'd like to find this, this is a paper by Jasper Schoutsfrate and Marianne van Romortel called Towards a Sustainable and Collaborative Data Model for Periodical Studies. I will put the link in the chat afterwards. And here, what this specifies is those relations that I just showed you before. So if we're going to collect information on a periodical, these are the characteristics that we want to collect and that are important. And then also, how are we going to store that information? So you see a key data property of place. So we're going to use place, but then we're also going to use geonames. So geonames is an ontology, a way that specifies and has uniform identifiers for identifying places. So it's not only about developing this model for ourselves, thinking about all the characteristics that we want to consider, structuring it as linked data, but also connecting it to other knowledge databases and other ways of other vocabularies to model this knowledge. After we had this linked data model, then we started collecting over a period of 4 years all this information on these over 3,000 individuals, organizations, and people. And we decided that in order to make this most publicly available for others, that we would share this on Wikidata. If you're not familiar with Wikidata, Wikidata is the public open data source that uses RDF for structuring metadata. And we integrated, for those that are interested, we uploaded this data using a Wikidata integrator. If you have questions about that, I'd be happy to follow up in the question and answer session about that process. But at the very heart of this model, and at the heart of integrating this then into the Wikidata model, which is then another specific way of modeling the knowledge, is that an editor edits a periodical. And then we define who is an editor, what could an editor be, what characteristics does an editor have, what is a periodical, what characteristics does that have. So everything else builds off that. It was in here, then of course, once this information was in Wikidata, that we have a property not only that identifies all of the items that we can find within our research project. So some of those would have already been on Wikidata, but others are those that we added. And that allows us a really, really fast way, which although this what you're seeing here is an endpoint, a query service of how we can go back and ask for this information from this linked data model. But most importantly, here is where you see item. And what I'm asking the query service or the computer to do is, can you please find me all items that have a tag of WeChange, so that emerged or were added from the WeChange database. Within 1.7 seconds, it returns 3,655 results. And so I could go through here and very quickly identify every individual that's also in the part of the WeChange database. Let's see. In addition, we can build on this query. So we can build on this request. Hey, computer, I not only want to find all of those items that have a WeChange ID, but I'd also like you to find those that have triple IFF enabled images in the Wikimedia Commons. And if you can find those for me, because then I would like to develop an app around this to show those images, right? So again, we wouldn't, without structuring the information in this way, we wouldn't be able to ask the computer to also help us find the items that we're interested in and build on that query of other publicly available information. So here, this results, that is this query. You don't have to understand all of that. It's really, we'll get there in the hands-on session. And then it results in a list of, yep, here are some items. These are the individuals that also have IIIF enabled images. It brings me then to that page, in this case, of a German editor and writer, and shows me that image there on her page. Another thing that we could look for is that we want to look for those within our database that had a certain citizenship or were born in a certain place, and also to identify, let's say, periods. So not everything that's in the database, but that they died before a certain period of time because I'm interested in the 19th century or 18th century. So really specific ways to go back and to go through this material. So here, that's the results of this query. So there's 65 individuals that died during the period of the Russian Empire that are then within this database. These are just some examples of, again, using the Wikidata query service, but again, more importantly, that we wouldn't be able to sort through and find these individuals unless the information was first stored as data, and then secondly, stored as linked data, and then thirdly, connected in a query to additional publicly available information stored in the same way. And it was this that allowed us to build that wrapper of that application of linked data stories. So none of these technical stories could be built without making that first step of structuring information in this way. I'm now going to give the floor to Sven. So I'm going to stop sharing my screen. And Sven will introduce Beltrans and will also add on my descriptions and definitions of linked data, and will lead up to the hands-on session. Sven, the floor is yours.
Great. Thank you very much, Julie. So yeah, as I already said, I'm talking about another use case where this Wikidata can be used on this kind of structured information. So let me quickly introduce it to you. So Beltrans is a 4 years project where currently 3 PhD students are working on. It just started recently, which looks into translation flows. So it is about the translations. So myself, coming from Germany, for example, we consume as well a lot of translated books from other countries. Now, in this very interesting case now in Belgium, where you have several languages, it's even more interesting as well to look into which books are translated from Dutch to French and from French to Dutch. And we consider these 2 big languages of Belgium because they are the most spoken languages. And we consider the period of 1970 until 2020, because this is also a time of a lot of change, let's say, in like the legal system in Belgium, where more and more autonomy was given to the local regions, which actually gives a bit more like a split between the cultures, you would think. And that's why it's interesting to look into literally translations within that period. This project is like a research project for 4 years, as mentioned, and it's a project together with KU Leuven and also UC Laval, where the different PhD students are coming from, and KBR as the Royal Library, who actually has a catalog of a lot of these books, is there the coordinator of this project. So if I talk about translations, what translation flows, what do I mean? Just imagine that if you would have an author and an author writes a book, that's okay. But now it's not just that from this book there might be another translation of that book. It always has to be seen within a larger context. So for instance, of course, at some point there will be a translation of this creative work, of this book. But of course, there's also a translator involved. And furthermore, there's also a publisher involved who actually publishes this book. And very interesting as well, especially for this project, is the date. When was this book translated? Like to get a bit more information about the context. Like a book translated in 1970 and in 1920, in 2020, there's a whole different context of the whole environment, let's say. But then, of course, also especially important how these translations, how they are like received and how they are perceived. What kind of critics do they get, and how often they are sold, other kinds of information. So here it is very important that you can see already everything in this graph here, everything of that, every bubble basically can have a lot of information, which is very interesting to look at, to study in this whole period, all these translations, because what might be the case for one very famous book in sort of translation flow might be completely different for other books, which might get more funding. Maybe there was like someone who got like a literary prize, and then this gave the incentive to actually make translation of that book. Or for just as to give a few examples, I'm also not an expert on this matter because, as mentioned, I'm the data manager, so it's more about the data and the backend. But actually, our PhD students are the one who actually going to use this data to answer interesting research questions on this matter. And this is actually then all these important information, like meta information about the translations itself, like when was it translated, why was it translated, who was publishing it, then also who was the translator, and very interestingly as well, where was it published. So for instance, we as the National Library, as the Royal Library of Belgium, also preserve all the works from Belgian authors and from Belgian publishing houses. But now, given this very unique situation where half the country basically is like Dutch speaking and the other half more or less is French speaking, a lot of the authors also publish books abroad, mainly in Paris or in Amsterdam, but maybe also in other places. So this means that these national libraries or other institutions, they have also very valuable information on Belgian authors, which we may not have, or which we also have, but they might have some additional information, which is also interesting to look at. So these are all a bit the challenges we look into that project, how we can provide the data so we can give the full picture in a certain way. And there it becomes very important as well when we look into linked data that we need data which is connected in a meaningful way. So this famous image basically shows a few blindfolded persons who look at an elephant from different perspectives. And it's very subjective. Depending on who you ask, you might see different things. One says it's a spear, another one says it's a wall, it's a tree or a rope. So it's very subjective depending on what you see. So we need like some sort of a shared model so we all agree on what we have here. And this is also the incentive in this case to look into linked data, because even though a spreadsheet or some sort of a database with tables might look like very structured, in the end, it's very specific. It was created for one purpose, to store the data in a certain way. And it might be that other people don't necessarily agree with how the things are stored, in which way, or even maybe how they are named. Imagine that you have a table talking in one column about a name or about authors. Another person might call them writers. Is now an author the same as a writer? Well, it depends, of course, what their intention was, what they wanted to represent. And there it becomes very important to get like this shared understanding, and also to express this with a technology. Like Julie introduced the linked data and this resource description framework RDF, which is then a way where these information can be represented in such a graph model you see here, where you really, in a really intuitive way, link things together. You don't have to understand complex table structures. It's really something relates to another thing. And the relationship has a certain meaning as well as the things. And to elaborate a bit more on that, especially also for Beltrans, what we did there is a so-called FAIR data corpus to represent all this contextualized information. So not just the author and the book, but also other information like who was the publisher, or was there maybe an interview with the author somewhere, and this helped maybe promoting the book better or something. And FAIR, if you're not familiar with the term, is an acronym standing for Findable, Accessible, Interoperable, and Reusable. It basically means that all the data you have should be findable. So that means it should have a unique identifier, so that globally you can always pinpoint to it and say, hey, this is the thing I'm talking about. Then this also helps if it's then indexed, let's say by big search engines, that if you look for it, you always find this information. Now, if you find information, of course, you don't want to end up in like some sort of a cookie banner saying, please now pay €5 to access this information. The accessibility also is a very important point here. Also, maybe even from a technological perspective. So that's the way you're going to retrieve the data should be in a standardized format. So you don't have to install or buy specific software just to use the data someone provided to you. And interoperable goes a little in a similar direction. It's really about maybe the data formats, like how can you connect things together? So in the image you see there's a graph with nodes and they are connected. And this is a very nice way so that data can be integrated and can be interoperable described, and you can combine them. So basically it's a format which is understood by everyone and every program, every human. So you can exchange something from point A to point B, and it's still understood to a certain extent. And then, of course, the last point, the reusable, is then also I mean, there's also something like copyright and intellectual property. So it's very important that also licensing information are made available as metadata together with your data. So everyone knows, how can I use this piece of data? That also means reusable, that it's clear for someone the provenance of this information, who created it when, under which circumstances, so I can assess better how trustworthy the data might be. But also that the metadata is available for a long time and is really there, even if the actual data has already disappeared. So if we take this idea now for the Birkholz concept or context in this case, it would mean that in this case, to be findable, then everything here gets a unique ID. And linked data is built on the web. And this is a very nice thing, because the web provides us already unique identifiers. If you go to google.com, there's only one google.com, because the name system of the internet with the web addresses is unique. And this is actually reused in this context. So you can put something on a certain web address, and then it's always, you can ideally refer always back to this web address. And then it's also retrievable via open protocols, because that's the way the web is built. It's basically an understanding of different protocols. Your browser knows how to speak to a web server, and other clients can do the same. And things are also described in an interoperable way, because we also use this graph model here. And this also enables us in this case to have rich metadata about license and provenance, because you can actually annotate each of these nodes in the graph, but even the relationships with this metadata, which is also then very interesting for the case of Wikidata, which is in the case, yeah, the Wikipedia, but for data, for structured information. So this is now a screenshot from a Wikidata page of the Belgian author Stefan Hermans. And basically, there are lots of information structured on this page. But this is a very interesting part, in my opinion, because here you see as well that there are also other IDs to other identifiers for other entities who have information about the same author. And that helps us actually to have actually the whole linked data, because you can really link things to each other. And this is also important because Wikidata, for instance, is like a crowdsourced platform where everyone can change things or add things maybe. But sometimes you find more qualitative information at some sort of an authority, maybe the National Library here, the Royal Library in Belgium, the National Library in France, because they also provide information, and they might have something which the other one does not have a piece of information. So you can actually follow this link to get the information also from other data on the web. So the next part, you saw already some queries, also Julie has shown you. I just want to quickly go over one example so you can see that actually all that is not some sort of dark magic or so. It's actually quite straightforward. So in this case, you can see a data expressed using this linked data format. This is now called the turtle format, which is, I would say, very human readable, because it really shows you this triple structure where you say Julie is a person, Julie family name Birkholz, and Julie given name Julie. So you see here all the three components. And now we imagine this is now one person, but let's see, we might also have some other data, which is then also about Chris and myself. And if you want now to retrieve data from this, let's say, data set, you can use something like this query, which is Sparkle query, it's called, which is actually a nice thing because this is a so-called declarative language, because you just say what you want and you don't say how you want it. You don't have to program and say, iterate, go over all my persons and select the one which has this and loop over it. You can just say what you want and you provide a pattern of the graph structure you would like to have, so-called triple pattern. So in this case, maybe let's just go over it. Let's do now the job the machine usually would do. We check each of the graph database, in this case, our data, And we see that in this case, you see that on the right, actually that fits the structure on the left. So, but instead of just selecting Julie, we use a variable and we say now we select any person, which is a schema of a person, and we want to get also the family name, the given name. And eventually from this pattern, we want to get the family name and given name to do something with it. Now, if we go over it, we see that in this case, it would not match. So we would not get a result because in this case, Chris doesn't fit in the pattern we were interested in. But if you go further, if you go to Sven in this case, you see again that Sven is a schema person, has a schema family name and schema given name. That's why it will be part of the result set. And that's basically how Sparkle works. So, and to give a slightly different example, here we have data sets again expressed in the same format, but now about something completely different, about cities and some locations. So we see here that Ghent is a schema city. We can define a label in a certain language, where we could also add other labels in different languages. And we say that this is part of the country Belgium. And the same we do for Brussels, where we also say that Brussels is a country and it links to also a Belgium, but they're actually both a bit slightly different. And if we would query now, maybe you could also think yourself for a moment, what do you think, which cities are actually part of this now slightly more complex graph pattern? So I'll give you a second and drink a bit. So in this case, you only would get Ghent because this triple pattern on the right is it's all connected. So basically, for Brussels, of course, it has a name here and the label and is part of a country. But the country we say here has also to be a schema country. But in this case, Belgium is a different kind of country, what someone else said a country is. And in order to avoid that, because often when you query something like Wikidata or other data sources, not every person or city in your data set might have all the information you want. If you don't take this into account, they don't end up in your result set and you actually miss a bit out. So what you can do as well is you just define this optional keyword. And in this case, you would also get Brussels in your result set because it's optional that it has to be a schema country. That's basically how such a Sparkle query would work. But in the end, yeah, the machine is doing it for us. We just have to write these queries in the end. Which brings us then also to the hands-on session, where I think the first query is one, or basically where you can all click on now. Maybe we can also share this in the
I'll do that,
chat.
Sven, yeah.
Yeah, great.
Yeah, so first, this is the first time that we're doing a hands-on session virtually. So we're going to see how this goes, so bear with us. But what we're going to point you to right now is actually a list provided from Wikidata of sample queries from the Wikidata query service. And here, perhaps I can share my screen, but actually, no, I'd like you to go there yourself so that you can see this. So if you can click on that link, these are a bunch of simple queries. So you have a query to find all the cats that are on Wikidata, the goats, the horses, cats with pictures, a map of hospitals, number of humans that are listed or that can be found in Wikidata, the number of humans found in Wikidata that were born in New York City, a list of recent events. So I would just like you to click on one of those. So that's a hyperlink. And it will bring you down to a Sparkle query. There you see a title. And then perhaps, Sven, can I share my screen for a second?
Yeah, sure.
Thanks. So hopefully you've all found this page then. So this is a list of these Sparkle queries that Sven and I just explained to you. Sven did a great job of explaining. So you can click on any of these sample queries here. And once you do that, it will bring you, I wanted to do cats with pictures. So here is the exact Sparkle query that you would need to put into a Sparkle endpoint or a query service. If you click here, try it. It's going to redirect you right to the Wikidata query service. That's query.wikidata.org. And then I want you to press the play button. Again, pick any query that you like. Press on this play button, and then you should, pending how large the results are, get some results. So in this case, I have some lovely pictures of cats. 39 results were found here. And although this is maybe a silly example, and some other examples as well are quite silly in the list, the point is to get you familiar with looking at these queries and how you would structure them. And also that how it brings together information. So what we'd like to ask you to do right now is just play around with some of these queries. Is there anything you'd like to add to that, Sven, about playing around with the wiki queries?
Maybe the only thing I could say is that also you saw in the beginning on the top of the page, when you are in the querying window, there's also an examples button, so you can actually directly load other examples as well, which are actually from the same page. So if you go now again, Julie, forward, where you just have been in the query builder. So here, if you click on examples exactly, then basically you can directly load the same examples as well. And Wikidata sometimes looks a bit scary because the parts of the pattern you see has these numbers P31 and so on. But if you go with the mouse over it and wait a while, you will actually get as well a tooltip mentioning what actually this is. Or maybe you have to click on it. That could be too. And also
I think I'm running something, so it doesn't want me to.
Yeah.
So here I have map where all the hospitals in the world are, according to the information that's stored on Wikidata, of course. Yeah, so first just play around with that. Again, you can either go back to that link that we sent or click on this examples button and see some of these examples here. Number of humans born in New York City, another one that I'll run. Take a moment there just to become familiar with the environment, run your mouse over these IDs. There you can see it. So here it's telling you this we changed, P19 is place of birth. Running the query here. Mine is humans born in New York City. Take a moment to do that. I'll stop sharing. We'll give you just a few minutes, and then I see a few people in the audience that I know, so I'm sorry if I pick on you in advance, but we just like to know, which query you did. And so if you kind of know that I might pick on you, you could raise your hand shortly and say, I did this query or I did something else, because the next step that we're going to do is we're going to ask you to try to change one of those queries. So if you already did that, that would be really great. But just take a minute now and play around with some of those. All right, so my query finished here of humans born in New York City. So within Wikidata, they found 18,150 people, including Boris Johnson, who knew? Lady Gaga. So again, another entrance point where we built a really specific question, a query, and then returned the available information. Does anyone have anything that they would like to share about a query that they did? One of the example queries. Mia, thank you. Please.
Yeah, I queried the horses with extra information. I think that's what it's called. Horses.
Cool. And what did the results look like? Lists of different types of horses? Or?
Lists of horses with IDs and their name, I think, and horse label. Also links to the mother horse and the father horse, the year it was born, the year that it died, if it's died, if it's a male or female horse.
Cool.
Yeah.
Great example of the really descriptive information that can be on there. Sven, would you like to walk us through the next queries, and I will find the Google Doc link for the Beltrans ones?
Yeah, sure.
Okay.
So let me quickly share my screen again. I think that's even also coming from the same examples, if I'm not mistaken. So here again, this is now, this looks a bit smaller, that query. So you just look for something. It's called airport now in this case, but that's just the name we gave. But yeah, you see that this is the P31 here, the instance of, what is Q12, of airport. And then actually we limit it as well using this. It has to be in range of Q31, and apparently Q31 is Belgium, so maybe you can even remember that for the future. So this now you could, for example, see, according to Wikidata, these are the airports in Belgium. And actually you can click them on the points. And that's the nice thing about the whole findable aspect of their data. They have an ID, and you can actually go on it, click on it, and then you see that this is the Hutzenhofen military airfield. And you can see lots of information about this airfield. And then, of course, you can also play around with that. And that's also a kind of a nice, more user-friendly bit of this interface. If you start now here to write.
Can you zoom in a bit on your screen?
Yeah, sure.
It's quite small, the text.
Yeah, I can actually try that. Never usually just with plus.
Yeah, with Teams that might be a bit tricky, but.
Yeah.
Yeah, good. Yeah.
Yeah. So if we go here to WD, let's start. And then it says already press control space to activate auto completion. Well, here you can look a bit more human-based, let's say, for, let's say, university. And then we see a list of possible classes, in this case, university. So now we change the query. I mean, we can still leave that named airport, it doesn't matter. But now we look for universities within Belgium. What is actually the second part? The coordinate location, indeed, of course, that's needed in order to show it in the map. We see a quite high density of universities in Brussels. No label defined. Yeah, that can happen with crowdsourced data sometimes too. That there is something found, but that's also the nice thing. Everyone can edit this now and can actually go and add values to that, similar to Wikipedia as well.
And these examples are here in the Google Doc that I just added of some of the Wikidata queries that we went through. So there's also then some examples from Beltrans.
Yeah. So shall I maybe show it, one of them?
Sure, please.
Maybe that looks a bit more complex on the first glance, but actually, let's show you the results first. Maybe that's also nice to know what we are actually looking for. This is now more or less like a nice graphic to see. Maybe you already guess it based on the labels. It's about genres, and specifically genres, like it's an amount. You see here novel 95. So we found here 95 novels, and we were actually looking for any work which has the author. We looked for the author because we needed that to check For our author is da, there's a Q31 again, it's Belgium. So we look for actually Belgian authors in this case. And then we got the information about the work, and then it was published. And then we actually filtered it to the period we use now in Belgium, for instance. And then there are some other things which made this query a bit more complicated because we wanted to get a sum of all the novels and of all the autobiographies. So don't get too much afraid of all these group by things. There's a similar query, actually, the second one, which actually is the same, just without the grouping and checking the statistics. So like this, you really see, like I limited in this case as well to only 300, so it doesn't run too long. But you see again the different results we got. So in this case, you see the title of the work and the author and when it was published. And of course, which genre it belongs to.
Right. So what we'd like to challenge you to do now, and then we'll move on to the question and answer session. So just one small task is any of the queries. Maybe it's the horse query that Leah mentioned. Maybe it's the pictures of cats. Maybe it's this last item that Sven gave of to find the list of Belgian authors from 1970 to 2020. To change some aspect of that, or go back to the airport example. And instead of airport, look at universities, look at, I don't know, trying to think of another example off the top of my head, but modify any of those queries and see what you get. And I might, since Ewout says that he really likes this interesting query, which is the last one, apologies for picking on you, Ewout, as our guinea pig, but he's also a PhD on the Beltrans project. I might challenge Ewout to look at that last query and change some aspect of it for finding information about. Great, you're both there. So PhDs of the Beltrans project for identifying those authors.
Wait, so we have to change something about that last query.
Change anything. Yeah, I proposed that you, Ewout, would do the last one since you said that it was interesting. Perhaps the more simple one, not the grouping.
And please share the screen if possible.
Yeah, just a second.
Thank you, Ewout. As I said, bear with us as we try to make this a virtual hands-on session. Normally we could be walking behind you and excellent.
Very difficult to do something like really on the spot.
I know.
I tried Sparkle queries, but I used the programming historian tutorial for it. There's a programming historian tutorial like here, using Sparkle to access linked open data, and I can really recommend it.
Great example. How about then just change the date? So instead of 1970 to 2020, which is the filter in red.
Yeah, indeed.
Just for individuals to see that how that results in the how it influences the results. So really just changing one aspect of it. Yeah. So this is already in this case with the grouping is already doing kind of a data analysis for us, but really from that knowledge base of Wiki data, instead of looking at the 70s, only from the 90s to 2020. So we already see here already a different graphic from what Sven showed.
Only 8 comics, that can't be right.
But that's actually also the interesting point that, of course, Wikidata is probably not used by a lot of bibliographers or so. And that's actually the interesting part where actually other data sources can come in, like KVR or like the National Library of France. And because Sparkle, this language, is a standardized language, so actually you can connect this and you can make a query over all these, in theory, over all these different stores to collect more information.
Great. Thank you, Ewout, for sharing your screen and walking us through that example and your, we really appreciate it.
Thank you.
Okay, I think that ends our hands-on session. To the best we could do this in a virtual way, unless you want to add anything, Sven?
No,
Okay.
not from my side.
Great. So thank you so much then for your attention today. And Sven, also thank you to you for doing this talk together. It was a pleasure. And I hope, as I had said at the beginning, that it's clear to you that it's really important that we make information available not only for humans to read, but also for machines to read. And the way that we do that is by structuring information in specific ways. And that in order to do that, that gives us lots of affordances and lots of new ways of bringing that material together, but also different entrance points into searching through and sorting through these needles and haystacks in our work. So we look forward to your questions, and thank you very much.
Thank you. Fantastic, fantastic, guys. Thank you so much, Julie and Sven. This was amazing, amazing. I'm personally so grateful. And look, other people are on the same page as me. And my students, I know that some of the subjects here we talked about already, and they were so into this, and so looking forward to the hands-on part, which was amazing. And I love the fact that you guys started, very easy with like explaining the concepts. And by the way, Julie, you did it better than I did in my course. So that was very useful. And then gradually moving on to more and more sophisticated aspects of linked data, examples, and then the hands-on part. Absolutely fantastic. I'm so grateful. And this is, to me, this is a dream format. And you don't get to see it that often, the lecture that, explains the concepts and then, culminates with the hands-on thing, and then wrapping up with conclusions and Q&A. For a DH talk, I think that's the ideal format. But again, you don't see it around that often. Before we move on to the actual Q&A session, there's something that I didn't mention. Julie shared with us, and I posted that on the Cheryl TCL website, a recent publication that is related to the talk. So please, I know I've encouraged my students, but for all those who are attending this right now, and those who didn't get a chance to do it, please check out this amazing article, very recent, and that speaks to the talk today on so many levels. And particularly the We Changed project and the way the networks of women editors were translated into linked data and embedded in Wikidata, right?
Yep.
That's impressive. The kind of work that you guys did is absolutely impressive. Okay, now, questions, comments? Je vous en prie, s'il y a des questions, des commentaires.
Can we already do it for our research? Maybe is that a question for Chris, maybe for an assignment?
Absolutely, absolutely. Absolutely. Stephanie, we didn't get to mention this during we did before we started the talk and the event per se. Stephanie is playing a key role in one of the projects that was referenced here today, Beltrans, right? So I'm excited to see you're in the audience, Stephanie. You should be one of the speakers as well. She's got a question on what about the scientific validity of the Wikidata? Well, yeah.
It's interesting, yeah. I don't know, Julie, you want to go first, or?
Sven, you can go first, and then I can follow up.
Yeah, so as mentioned, Wikidata is a crowd-based platform, so of course there is a lot of things going on there as well. But what is special also about Wikidata is that you also saw it if you go to a Wikidata page where you have all the structured information. Sometimes you see this references button, because actually every claim you do on Wikidata, you can add a reference to it where you say, okay, this is important provenance information about this comes from this other source. And there are also some sort of community guidelines for people who are actually working on Wikidata to what things actually need a claim, what needs a reference, and which claims are already self-evident and you don't need to specify it more. But of course, that's not always the case that these references are given. So yeah, the scientific validity might be a bit questionable. I haven't worked myself in depth with Wikidata myself, but I assume there might be there's maybe also some related work on that, maybe some studies, I don't know.
If I can add to that, I think that's a really important question, and that's also asked a lot in the context of libraries and archives. Why would I put my data on Wikidata? Someone's going to change it. Wikidata should never, ever be your one authority source of where you're putting your data. You have your own database for your research project, your catalog for a library. But I think it's clear, and I hope it's clear in our talk today, that by making that information available as linked open data, it allows you to connect with many other resources to validate those things. So if we want to talk about what's the scientific validity of this, well, let's look at the identifiers that Sven gave in his example. That there we saw the BNF, other libraries and archives that have, like, let's say, the same person or have information on the same periodicals. So it's a way not only to enrich our sources, but even cross-check the information. Imagine that, you know, two different libraries could have different birth or death dates, and they could both be authorities. But the way that maybe we can figure that out in a really efficient way, and to also discuss what is the discrepancies of this. Oh, where can I go back and find that provenance of that information? I can do this really efficiently once that information is stored in this way, to do those SPARQL queries to check. So I would say that certainly it should never be your core source. It should be an entrance point back to that information, but also as a way for you to cross-check that information. And I want to provide one other example, which I didn't mention today, which is that Wikidata is a community. So detailed in this Semantic Web Journal paper that I had just put the link in there, and also on the website, we detail some of the interactions that we had with the community. So for example, we inserted the dates and they were all standard, but we had records on Russian authors and editors, which were using a different calendar, the Georgian or Julian calendar. And the community was the one that mentioned that to us, that, like, you have to change this date format because this is not accurate for the specific person and period that you're talking about. And that helped us also enrich our own database, that we could keep both of these items mentioned there. So the community is really active, and that also helps to ensure this validity. But I'm sure your data is going to get messy, but this is never going to be your one-stop, most valid data source. That's not the point of this. This is to make it findable, reusable, and interoperable with other sources.
Thank you guys for the response to the question asked by Stephanie Van Asten. Stephanie, do you have any further comments on this, or? Okay, thank you. Okay, any other questions or comments? Des questions, des commentaires? Big thank you again for everyone. Yes, well, thank you for sharing your screen and doing being the guinea pig, as Julie put it. Okay, and brilliantly so. Okay. Well, I have a question to since I referenced your recent article and the impressive and telling the story of stories and using science stories, right? By the way, and it's something that you mentioned during the part of your talk, Julie. You use a data integrator, right? I know you detailed that in the article, but it might be interested to explain that to our audience today as well, briefly, if you can, if you would.
Great. Yeah, let me. I'm just going to share my screen again because I have the other slide.
Yeah, by all means, yes.
Which is here. So indeed. So in that paper, we detail the really practical steps of how we move from our own database to modeling the data in Wikidata ontology, and then really importing that into Wikidata. So there's not only a lot of thinking that has to be done about modeling this knowledge, which we did as a team, and I mean a team of humanities experts, but also technical experts and also experts of the Wikidata community. And then once we said, yep, this is a match. So to think about that, imagine that you have a spreadsheet and you have in that spreadsheet, one of the columns is the representation of date. And you say, oh yeah, but in our database, we stored the date like this. Oh yeah, but in Wikidata, the information is stored like this. Obviously, we have lots of tools of Open Refine for helping us do that, but there is this process of remodeling that information or categorizing things in different ways. So that was one part of it. But then the technical aspect, of course, was once we knew what the model was, once we knew how to map it from the way that we stored and thought about the information before and the way that it was in Wikidata, we use the Wikidata integrator to import the data. So you can add data now in Wikidata just manually. So if you have a login, you can just go in there, make edits. It keeps track of these edits. But if you're going to do this in bulk, so we had over 3,000 items. That wasn't something that we were going to do by hand. And also there were a number of these people or periodicals or organizations were already in Wikidata. So it wasn't always just a straight, I'm going to import this and it's a brand new item. But it again was this cross-checking of, okay, this item already exists. Is this the same person? So to help you import data and deal with these kind of property issues, there is the Wikidata, it's a Python module called the Wikidata Integrator. So it uses the Wikimedia API and the Wikidata Sparkle endpoint to do this in bulk. I want to say if you're going to use that, great. If you're going to import 3,000 items at once, don't do it. Do first time 10 and then the second time 100. So first, so that you can recognize some mistakes and so that the community can alert you so that you don't have to do it all over again. But there is, a really nice, straightforward script which integrates those things, which was developed by Angela Wagemeister. So another really active researcher in the Wikidata community, but more importantly in linked open data, who's also a Belgian-based researcher. So thank you to Andra for that.
And thank you for this really rich and useful reply. We have a longish question from Eric in the chat. How to add women editors to this database, quote unquote. But that's not really a question for this session. And does Wikidata replace the original We Changed database? If not, how to maintain updates to the original database in Wikidata in an easy way?
So that's a really good question. As I'd answered in my previous question, no, the We Changed database exists. Right now, it's being stored in NodeGoat, which is a collaborative relational database, which also allows you to use a linked data model. So you can export it as JSON LD, which was obviously helpful in this process from the technical aspect for remapping. But that's our authority, that's our master file. The master file is the We Changed database. The goal of putting this information on Wikidata was to make it more publicly accessible, and with the goal of developing that wrapper of the app to tell linked data stories as an even more user accessible way to navigate this machine readable material. How do we maintain updates? So that's something that we spoke a lot about. So first, unfortunately, I guess fortunately for the PhDs, the European research project of We Changed ended last year. So that database is being maintained by Professor Marianne van Romortel of the English Literature Department at Ghent University. And she is adding to that, as well as other students that are working on that. And we developed then a system for how annually that we would do a cross check. So we would, again, using that Sparkle query endpoint, we would go in and we would find all of those items that were marked as we changed items, and then we would then do an export and do a cross check then of all of the data that we have in the, let's say, the master file. And given that that data is mapped in the same structure, it's very easy for the machine to go through and say, oop, this is a new item. Oh, you didn't have this here before. And then in some cases, we haven't done that yet. So this process, we have spoke about how we would do it, but we've only finished the process. We're just coming on over a year, so we haven't like done that technical process yet. But that's the idea of thinking that because we have the Sparkle endpoint, we'll be able to make that list, we'll be able to cross-check it, and then pending how many additions we have from the master to consider again doing an import or to make changes. But that also was a way, speaking about quality, that we thought about that we would be able to look at maybe items that had changed that would also spark a question for us, like, why was this changed? Like, what's the provenance of this? And even go back, because you can see who's made that edit and have a conversation with that person as well. So it's a different way of engaging with the community through Wikidata. And it certainly takes, different expertise and different little social and practices and organizational practices for how you want to implement it in your organization. And the way that we did it on the We Change project doesn't mean that other institutions it will be the same. You see various ways that organizations and research projects are using the platform. And I'm not sure about how to add women editors to this database. So
I think I have to contact Prof. van der Motel and Gent, maybe.
To add to the We Change database. Yes, please. Yep. So if you would like to make contributions to this, well, first I would say do one of the queries for looking for the We Change items. I don't think we had that yet on our Word doc, but or the Google Doc, but I'll put one of the queries in there so you can find the ID and see if the editors are already on there, because then you can see which information we probably have. And otherwise, indeed, contact Marianne van Romortel. She's managing the database and the project.
Okay. Thank you.
Okay, thank you for the question, and thank you for yet another really substantial answer. Okay, any other questions or comments? Okay. What is the original source for, thank you, Laurence, for the question. Un grand merci. What is the original source for Wikidata veracity? By example, the original version of The Sorrow of Belgium is 1970. If I'm not wrong, Wikidata is started out 1983. Oh, yes.
Sven?
I guess it depends on this case, because usually, someone edited. In Wikidata, you can actually see, similar to Wikipedia 2, I'm just wondering where there's a view history as well on the bottom right, top right. You can even see who edited it and what was changed. Like once I even found myself already on Wikidata, I didn't even know how I ended up there. But apparently there are also some automatic imports from other web services where they had like a CV of mine.
It looks like Stephanie. Stephanie's got the answer to that.
Yeah.
She knows what she should know. It's her subject, right? Thank you so much, Stephanie. Okay. Well, yes. You're old enough. Okay, good for you, Eric. Okay. Good. Any other questions or comments? If not, we can wrap it up here. Thank you so much again, Julie and Sven. This has been amazing. We recorded it, and we'll keep in touch on. It's going to be the students for now to watch it, and I'm sure that projects will emerge here at UC Leuven among our students, and not only based on the really useful information and technical aspects that you guys shared with us. today. We'll stay in touch on that as well, on the potential future collaborations. Students, senior researchers, or other people here. And a big thank you again. And for those who don't know, there is a series of the discussion group at the KBR, co-led by Julie. And the first session for this year is scheduled for this Monday, right? This coming Monday. So you guys are invited to join in. The announcement is up there on the KBR website, right?
I don't know if it's on the KBR website, but Leah, are you still here? Can you put the link to Scholarly Tales for the? Thank you, Leah.
Okay.
So that's the digital humanity early career researchers in Belgium that are interested in digital humanities. We have a monthly virtual discussion group, and anyone is welcome to join us. You just need to sign up.
Yeah, it's a really, really interesting crowd, and the presentations are amazing. Again, very useful. Keep checking out the KBR website for the other events and event series, like the DH Heritage series. That also is organized by Julie and the Digital Research Lab, right? Co-organized. And as for our guest lecture series, we will continue in November 24th. Alors, la conférence prochaine est prévue pour le 24 novembre. La conférencière sera Florentina Armachelou, Université de Luxembourg. Une conférence sur zoomable text and scale, the issue of scale in digital humanities. Alors, une conférence très, très intéressante donnée par une chercheuse remarquable, comme les chercheurs aujourd'hui. Je vous encourage chaleureusement d'assister et de poser des questions. Et après ça, en décembre, une conférence en présentiel donnée par Michael Sinatra de Montréal. Alors, il va visiter en décembre et donner la conférence en présentiel. Michael Sinatra est le président de CREAN, le Centre de recherche interdisciplinaire, humanité numérique à Montréal. Une présence vraiment bien connue dans l'Amérique du Nord et pas seulement là. Et on peut être une autre conférencière en décembre, aussi canadienne, Diana Inkpen, qui a donné une conférence en distanciel l'année dernière, mais elle peut, je dois confirmer, mais on a discuté aussi d'une conférence cette fois en présentiel. So we're having these amazing events coming up in November, December. November, like I said, November 24th at the same time, 2 p.m. Florentina Armachelou, University of Luxembourg, with a fantastic talk on zoomable text and the issue of scale in digital humanities. And then in December, Michael Sinatra, the president of CREAN, the Center for Interdisciplinary Research in Digital Humanities in Montreal, a big name in Canada, North America, and not only in DH, is going to be here to give an in-person talk. And we might have a second guest lecture in December, returning Diana Inkpen of University of Ottawa, a big name in natural language processing, world-class researcher, just like the researchers we had today, but this time in natural language processing, so returning after an online talk that she gave last year, part of TNT, now an in-person one with an NLP subject to be announced. Okay, thank you so much to our guest lecturers today. Amazing talk. We'll stay in touch. Thanks so much again. Have a good one. We'll stay in touch. Thanks. Bye now.
Thank you, Chris.
Thank you again.
Thank you very much for organizing.
Thank you again, Julie and Sven, everybody else. Thank you. Bye now.
Okay, bye, Sven. Thank you. It went really well. Oh, dag Dieter.
Dieter is there.
Oh, is Chris still here? I think we're still being recorded. Het is nog steeds aan het opnemen. Oké, dag. Bye.